Hi, I'm Luka Jojic and welcome to my video on how a doorbell works. Here we have a doorbell. We've all seen one and we've all used one, and we all know that they make a ding or a ringing sound when you use them. But a key component of a doorbell, which usually isn't actually noticed, is an electromagnet. A key feature of an electromagnet is that it has a magnetic field travelling from its north pole to its south pole, and this field is critical when a doorbell is making a sound. So as you see here, we have a normal electromagnet from north and a south pole, and you can see the field is two different colours travelling around the magnet. So I've told you about the electromagnet, but what actually happens in a doorbell? So to understand how the doorbell works as a whole, first we have to look at what is inside the doorbell. Doorbells are low voltage devices, and this means that they require relatively little energy to operate. An important part of the doorbell mechanism is the transformer. In essence, the transformer is two coils of wire wrapped around an iron core in different frequencies, and this causes voltage to change. A transformer's job is to change the regular 120 volts household current to the lower voltages between 3 and 12 volts. However, this is dependent on the doorbell and how it operates. The second and potentially most important part of the doorbell is the electromagnet. You could almost refer to the electromagnet as the heart of the doorbell. Essentially, electromagnets are coils of wire wrapped around a small piece of magnetic metal. The key component of an electromagnet, which makes it compatible with a doorbell, is that when electricity or charge passes through the wire, it creates a magnetic field around the wire. So here we have a very simple electromagnet. We have the coil wrapped around the wire, and we have the electricity passing through. Because there is electricity, this means that a magnetic field is therefore present. This magnetic field, in turn, pushes against a pin, causing this pin to hit a piece of metal located in the doorbell. This first strike causes a ding, which is a very familiar sound to us all from the doorbell. But because magnetic field orbits around and out of the wire, this also hits a second pin, which is slightly further away, causing a staggered second sound that we know as a dong. So the frequencies of sounds causing the ding and the dong are based on the sizes of metals which are being struck. This obviously depends from doorbell to doorbell, but in essence, by pushing the doorbell button, you are allowing electricity to flow through the electromagnet, causing a field which in turn strikes the pins, making the sound, alerting somebody that you are at their door. So you have two different types of doorbells, a buzzer doorbell and a chime doorbell. Now this is a very simplified example of a circuit, and the buzzer doorbell obviously contains a switch and a speaker. So if you press the doorbell button, you will close the switch, allowing electricity to flow through the speaker, causing a buzz. But in a chime doorbell, it's the same principle, but when you press the switch, this causes a magnetic field around the electromagnet, which causes the chimes in a sense. So it is the same idea, but with different components. However, a normal example of a circuit with a doorbell is significantly more complicated because you have to go to and from the mains electricity of the household. How are doorbells changing and how are they going to change? Now, the actual idea of pushing a button, playing a sound, letting somebody know that you're at the door is good, and it's going to stay the same. But this is going to change in the future, and you may already see it with certain houses. So we're going to be getting rid of the ding dong, allowing you to play a custom sound when your doorbell is pushed. But this changes the circuit because it means you no longer have chimes and you no longer need a buzzer. So I hope you've learnt that what seemed very simple at first is not actually as easy as it seems. But for now, it's bye from me, Luka Jojic. Thank you for watching.